The question is, a system with the transfer function y of s by x of s equal to s by s plus p has an output y of t equal to cos of 2t minus pi by 3 for the input signal x of t equal to p cos of 2t minus pi by 2. Then the system parameter p is, the options are first option root 3, second option 2 by root 3, third option 1, fourth option root 3 by 2. Now we will see the solution to this question. Given that the transfer function h of s, which is nothing but y of s by x of s, is s by s plus p. Writing this transfer function h of s in terms of j omega, we can write it as h of j omega equal to y of j omega by x of j omega equal to j omega by j omega plus p. Now we need to find the amplitude response and the phase response of this transfer function. That is, we need to find mod of h of j omega, which is nothing but mod of j omega by mod of j omega plus p, which comes as omega by root over omega square plus p square, because mod of a plus ib is nothing but root over a square plus b square. Now we will find the phase of this transfer function h of j omega, which is nothing but 90 degrees minus tan inverse of omega by p, because the phase of the j value is 90 degrees and the phase of a plus ib is nothing but tan inverse of d by a, that is tan inverse of imaginary part by real part. Now we have found the amplitude and phase responses of h of j omega. Given that x of t is nothing but p cos of 2t minus pi by 2, and this is nothing but the input, and given that y of t is cos of 2t minus pi by 3. Now we know the fact that if the input is sinusoidal, the output is also sinusoidal, but with a different amplitude and phase response. That is, the amplitude will get multiplied by the amplitude of the transfer function and the phase will be modified by the phase of the transfer function. As shown, y of t will be some amplitude of the transfer function h of j omega into the input, which is nothing but the sinusoidal or cosinusoidal of the same frequency but with the different phase modified by the given transfer function. Now we can clearly see that the output amplitude is 1 and the input amplitude is nothing but the p. So we can clearly see that mod of h of j omega is nothing but output amplitude by input amplitude, which is nothing but 1 by p. But we have already found the magnitude of the transfer function, which is nothing but omega by root over omega square by p square, which is marked as first equation. Substituting this, we can get omega by root over omega square plus p square is nothing but 1 by p. But in the given question, the omega value is nothing but 2, because it is of the form cos of omega t minus pi by 2, and in the output also the same frequencies appeared. So omega is nothing but 2. Substituting the value of omega, we can get as 2 by root over 2 square plus p square whole root equal to 1 by p. Now squaring on both sides and rearranging the terms, we can get it as 4p square equal to 2 square plus p square, which we can write as 3p square equal to 4. This implies that p square equal to 4 by 3 and p is nothing but 2 by root 3. So we have found the value of parameter p, which is asked in the question, and hence we got the final answer, which is nothing but the option B, and hence the final answer is B. Now we can also do the solution for this question using the phase response of the transfer function. That is, we can also use the angle of h of j omega expression, which is nothing but the second equation as marked. And now we need to find the phase difference between the inputs and outputs. Here the phase of the input is minus pi by 2 and the phase of the output is minus pi by 3. So angle of h of j omega is nothing but, which induces the change in frequency, is minus pi by 3 minus of minus pi by 2. That is minus pi by 3 minus of minus pi by 2, which is nothing but pi by 2 minus pi by 3, which we get it as 3 pi minus 2 pi by 6. It comes as pi by 6. We have already found the angle of j omega value, which is nothing but given by second equation, that is 90 degrees minus tan inverse of omega by p, which is nothing but pi by 6, as we have found the phase differences between the input and the output. Now we can write it as pi by 2 minus tan inverse of omega by p equal to pi by 6. This implies tan inverse of omega by p equal to pi by 2 minus pi by 6, which is nothing but 3 pi minus pi by 6, which comes as tan inverse of omega by p equal to 2 pi by 6, which is pi by 3. Therefore, we can write omega by p as tan of pi by 3, which is nothing but root 3. Now we have already know that omega value is 2, which comes as 2 by p equal to root 3. So the value of p is 2 by root 3. So by using the phase response also, we got the same answer, 2 by root 3. Now the advantage in using the phase response is nothing but the calculation in some questions becomes very easy. So we can prefer phase response as compared to the magnitude response in solving these type of questions. So the final answer is 2 by root 3.